All right, guys, so we are going to be going over section 6.4 and 6.5, and if you notice, this is titled special parallelograms, okay? So all of the figures that we're going to be talking about today are parallelograms, which means that they hold the same 7 properties that normal parallelograms have, okay? So the first parallelogram that I have, or special parallelogram that I have, is a rectangle, all right? And we know, all right, the general idea of what a rectangle is, all right? But what the definition of a rectangle is it's a parallelogram with 4 congruent angles. Now, we can keep going from there. All right, so it's a parallelogram with 4 congruent angles. And what we know is that those congruent angles have to be right angles, okay? So they have to be right angles. So if I would draw a picture of it, we're going to draw a rectangle. And we're going to mark that all 4 of these angles have to be right angles. And so if you would think then about what you know, like about rectangles, a lot of students will say, well, we know that the opposite sides are congruent. And that's true, but the reason why that's true is because it's a parallelogram. So again, those 7 properties, all right, of parallelograms are also true about rectangles, okay? All right, now I'm going to skip over square and I'm going to go to rhombus. So what a rhombus is it's a parallelogram with 4 congruent sides. And so if we would draw a picture of that, all right, we're going to draw like a slanty square, okay? And this time we know that all 4 sides have to be congruent, okay? Now, again, because it's a parallelogram, we know that the opposite angles have to be congruent, so that's also true, all right? And same with all the other 7 properties, all right? But we have to have 4 congruent sides. Now, the last one is a square, and a square is like the most super special parallelogram, all right? So what a square is it's a parallelogram with 4 congruent angles and 4 congruent sides. Okay? So if I would draw my square, it's super special, all right, because it has all the properties of a rectangle and a square. I'm sorry, a rectangle and a rhombus. So I'm going to go ahead and mark, all right, all 4 of those sides congruent, and then all 4 of those angles as congruent. So those are our special parallelograms. And what today's focus is about what else is additional about these special parallelograms, okay? But let's first describe, let's decide whether the following statements are always, sometimes, or never true. So if you look at letter A, it says a square is a rectangle. And this is going to be always true, all right? So a square is always going to be a rectangle because a square is always going to have 4 congruent angles, okay? Now, C says a rectangle is a square. All right, this is only sometimes true. It is only a square when all 4 sides are congruent. Let's go over to D. So then it says a rhombus is a quadrilateral. This is always true. A rhombus will always have 4 sides. All right, so that's always true. And then B, a rectangle is a rhombus. I really like this question because a lot of students go to never, but the answer to this is sometimes, because there's only one case when a rectangle is a rhombus, and it's when it's a square. Okay, so if you think of like an old school Venn diagram, all right, where I know you've talked about these before, probably in elementary school or in middle school. So like the overlapping circles, okay? Like if this is a rectangle and then this is a rhombus, the only time that they have something in common is whenever it's a square, okay? So that square is when they are similar to one another. Okay, so we now have 4 more properties, okay? And this is all about like the diagonals, all right, of these figures. So if we look at theorem 6.13, all right, it says that the diagonals of a rectangle are congruent. Okay, so if we would draw a picture of that, so the diagonals of a rectangle are congruent. All right, I'm going to draw my rectangle. Let's label it A, B, C, and D. And let's draw in our diagonals. Okay, and let's go ahead and mark that intersection point and label it as E. So what I know about this, because it's a rectangle and the diagonals are congruent, I know that AC is congruent to BD. But I can almost take this one step further, all right? And I can now state that because, so we're going to combine two things, all right? So because I know, all right, that these two segments right here are congruent, right here and right here, okay? And I also know that they bisect each other because it's a parallelogram, all right? My notation here is very important because I actually know that all of these parts right here, all right, have to be congruent, okay? So that's what's going on with the diagonals of a rectangle, okay? Now let's talk about the diagonals of a rhombus. So there's actually two different definitions or theorems about the diagonals of a rhombus. So the first one is the diagonals of a rhombus So the diagonals of a rhombus are perpendicular. So the diagonals of a rhombus are perpendicular. Okay, so let's go ahead and draw a picture of that. So I'm going to draw my rhombus. And let's go ahead and mark all those sides right here as congruent. And we're going to go ahead and mark our diagonals in there. And what I know is that they're perpendicular, so I'm going to mark that as a right angle. Okay? So there we go with our diagonals of a rhombus. Okay? Now, the next part, though, of the diagonals of a rhombus, all right, so the diagonals of a rhombus are angle bisectors. Okay, so the diagonals of a rhombus are angle bisectors, all right? So what that looks like is if I go ahead and draw my rhombus again, okay, then I'm going to mark in, all right, my diagonals again. I'm going to again mark that they're perpendicular because that's true. And so then from there, all right, here's again our notation. So because we know that the opposite angles are congruent, all right, I now need to state that these two angles are congruent because it's an angle bisector. But then I also know these two angles right here are also congruent. So all four of those angles are congruent. And that's also true about these two. All right, these two angles are congruent and these two angles are congruent. So that brings us now to Theorem 6.16, and this is all about squares, all right? And the cool thing about a square is it's actually the most special shape, all right? So the square, it says a square contains all the properties of rectangles and rhombi. Okay? So if I would go ahead and draw my square, it has everything special about it, okay? So let's just try to notate everything. So one thing we know about the square is that they're all right angles. And that's coming from the rectangle, okay? What we also know about the square is that these are all congruent. And that's coming from a rhombus. If we draw in our diagonals now, all right, we know that they're perpendicular, so we know that this is a right angle. But we also know that they're congruent. So that means that all 4 of these parts right here have to be congruent. And then the last thing that we know about it, and I'm going to do this in a different a different color, all right, is that the diagonals are also angle bisectors. Now, if you look at my notation here, all right, because I'm bisecting all of these congruent angles, all 8 of these angles are congruent. And we also know that all 8 of them equal 45 degrees. Okay, so that's just something else. So squares, all right, squares are super special, all right, has all the different properties. So I'm going to pause here, all right, and then we'll go into applying.